Again, I'm hoping that you've studied the material in the sections 1 through 17 and you feel comfortable with that material. But like anything, you're comfortable, but you still need to review the material. And this is what's known as a cumulative review for the course Math 120. So I'm not going to say this is every single type of problem you could see, but for the most part, these problems should be somewhat familiar to you. All right. When I say somewhat familiar to you, you may have to go back and review. So let me click on that. And I'm going to break it into pieces because it's a long review. But, I do provide answers for you. And sometimes I throw some Sage code in there. And the reason for that is I just want to get you more familiar with Sage. All right, a computer algebra system. And I think it's important you do become more familiar with a computer algebra system. But my goal here is just to do it as I was, just taking an exam. I'm not using Sage or my calculator or my cell phone or the internet. I just have a piece of paper and pencil, and I'm going to do these problems here. Now, granted, one day I might do it a little different than another, but the bottom line is I know what my goal is, to be able to work a problem and be somewhat flexible. But here's the deal. They got answers down. And these answers aren't like, oh, gee, that looks right. I want to see if it is right. I want to see if that's the right answer. Who knows? Maybe I made a mistake. So we'll be doing these problems over here, and I'll break it into parts. So let me go back to the whiteboard. I'm going to need 1 second to do so. And I'm going to share a new screen with you. All right, we're on the whiteboard. And so what I'm going to do, and certainly what I'm talking about over here is I just want to do, like problem number 1. And I'll pull it on the side for you. Right over here. And I'm going to see if I can do it. And I'm looking at it, and they want me to solve an equation, actually. And they say, for what values of x is this true? I don't know. Let's take a look. So f of x is equal to sine x. And f of minus x is equal to sine of minus x. And I think you probably know, at least I hope you know, that the sine of minus x, it's an odd function, right? And what would that be? It would be minus sine of x. All right. Let's see if we can think through this one. And I'm going to just kind of graph it out, understand what I'm talking about. And I'm going to do this guy in green. And I'm going to do this guy in blue. Let's do the blue guy first. And it's the opposite of sine function. I know what that looks like. It sort of looks like this over here. I'm just going to do a 1 cycle now. You could do as many cycles as you like, but I'm just going to do a 1 cycle now. And now I'm going to put the green curve down. And that's just a sine function. What does that look like? Click this over here. Now, what's their question? Where are they the same? Well, I'm looking at it. They're the same here. They touch each other. They're the same here. And they're the same here. And I bet this keeps going on and on and on and on and on forever. It's cyclic. The question is, what are these values over here? That's 0. That's pi. And that's 2 pi. So what am I going to say? This is true. These equal one another, multiples of pi. So it's true for multiples of pi. Let me point out where that answer is. All integers multiple of pi. For example, 0 times pi is 0. 1 times pi is pi. 2 times pi is 2 pi, yada, yada, yada. But they keep repeating themselves cyclically every pi. All right, that's number 1, not that bad. And certainly I'm not going to say it was an easy problem, but it was a doable problem. So let me go problem number 2. And number 2 also looks reasonable, but maybe I can't remember. Maybe I got to go back and review. Who knows? Now, let me write this one over here. This is a sum formula, right? So it's going to be cosine of 240 degrees times the cosine of 225 degrees minus the sine of 240 degrees times the sine of 225 degrees. Now, granted, we're not in the beginning of the course, and we're at the end of the course. And I just want to, kind of walk through it with you a little bit. All right. So 240, what would that be? That's sort of like in center position 180, right? And then I got to go 60 degrees more. So somewhere over here about. So what's the reference angle? 60 degrees. And this is 240. I know what that looks like, by the way. Sort of like this over here. All right, so what's the cosine going to be? Well, that would be minus 1/2. Right, let's see, minus 1/2. Yeah, not bad. All right, I got to do the 225 now. And where's that going to be? Well, that's going to be what? Over here, 225 degrees. What's the reference for this one over here? 45 degrees. Well, I know that one pretty well. That's minus 1/√2. Let's keep going. And let's do the sine of 240. And I'm kind of looking at my picture. And that's going to be minus √3 over 2. And what's the sine of 225? Well, I'm kind of looking at my picture. It's minus 1/√2. Well, the denominators are the same in both cases. I hope you realize that. It's 2√2, right? And what do you get for the numerator? Well, minus 1 times minus 1 is 1. And then you get minus √3. That's done. Let's go to the next one. Ooh, this one, the vertical asymptote, x greater than 0. Oh boy, this is going to be a tough one, I think. Put it over here. Let's take a look, see if I can handle it. So what do we do again? I guess we got to do like begin end, right? And the tangent curve begins when its argument is minus pi/2. And it ends when its argument is pi/2. Oh, I made a mistake in copy. I'm sorry. I get my eraser out. Because I said the argument was something that's not its argument. The argument was an x plus pi/2. It's pi/3, right? I apologize for that. All right, I got to do this now. This is going to be the tough part. X equals minus pi/3 minus pi/2. X equals, common that would be 6, right? And let's see, you would get minus 2 minus 3 minus 5, right? And let's do this guy over here. And what do you get over there? You get x equals 6 again, right? That's going to be minus 2 plus 3, which is pi. So I'm going to point out the begin and end of a tangent function is really just its asymptotes. And I'm going to draw the picture of it. Not that you have to, I didn't ask you to draw a picture of it. I want to try to understand what they're talking about. So I'm going to say pi/6 is here. And minus 5/6, that's 1 pi/6, minus 5 pi/6 over here somewhere. All right, this is x equals pi/6. And this asymptote over here is x equals minus 5 pi/6. Let's see if I can do center of that. And the center is over here somewhere, right? I'm not a very good artist. All right, let me remind myself what the curve looks like. Yep. I know the curve looks sort of like this over here now. All right, let's see if we can do the center of that. That's minus 4 pi/6. So minus 2 pi/6 right over here. All right, we'll take a look at that. Yeah, it looks pretty good. What was our question though? This is really important. It says, find a vertical asymptote. I found two, but they want it to be greater than zero. Well, this one's greater than zero of the graph. I just graphed it. That is closest to the origin. Well, lo and behold, I think I found it, pi over 6. All right, let's go to number 4. And put this over here. They want me to expand something. I'll do this one now. Okay, let's take a look at it. Cosine formula, let's write this down. This is going to be equal to cosine alpha times cosine pi over 4 minus sine alpha times sine pi over 4. Well, cosine alpha, what's cosine pi over 4? 45-degree angle is pretty simple, 1 over root 2. Hoping by now you got that covered. Sine alpha, and the sine of pi over 4 is 1 over root 2. And if you simplify this, then they both have the same denominator, root 2, and you get cosine alpha minus sine alpha. We're done. Let's go to number 5. Ooh, number 5 looks tough. Let's pull them aside. They want me to simplify that, and that looks like it might be tough. Wouldn't it be nice if exams had answers on it? I knew how to get there. And exams don't have answers on it. I'm looking at 1 plus 10 squared. It looks a little bit familiar to me. I'm going to write this over here for you. So sine squared theta plus cosine squared theta is equal to 1. Well, you could divide by cosine squared. You would get tangent squared theta plus 1 equals secant squared theta. So now I knew that, right? We really should have done that. So 1 plus tangent squared theta is really secant squared theta. Now 1 plus, oh, this is going to be a tough one. So cosine 2x, right? So I just put cosine 2 theta down. Well, I'm hoping you kind of remember that the cosine of 2 theta, right, is like going to be cosine squared minus sine squared. Right? I'm hoping you've seen that before, right? A long time ago, double angle formulas. This is going to be written as 2 cosine squared theta minus 1. Or it could be written as, let's see, sine squared theta could be written as 1 minus, 1 minus cosine squared. Cosine squared theta, 1, oh, it'd be 1 minus 2 cosine, 2 sine, I mean. Wow, there's so many choices. What am I going to do? I'm going to pick one. And I'm going to pick this one. Let's write it down. It's going to be 2 cosine squared theta minus 1. Let's keep writing this. Secant squared theta is, oops, didn't mean to do that, is 1 over cosine squared theta. And what's this over here? It just turns out to be 2 cosine squared theta. And what's this thing simplified to? Well, the cosine squared thetas disappear, conditionally, by the way. You get a 2. All right, let's go to number 6. And number 6, let's push this on the side. Give me a second. Done with that business. And I'm going to pull 6 on the side now. By the way, I'm not interested in the Sage code. Let's take a look. Find the minimum value of g of x. Let's write it down. Well, I guess we could do that begin and end stuff. But here's my problem. I don't think I want to graph it. What I want to do is I want to say that this thing here, the most it could ever be is 1, right? And the least it could be is -1. So let's take a look at it, and just one step at a time. So I'm wondering, this is definitely a cosine curve. Whatever it looks like, it's definitely a cosine curve. And there's going to be some value there and some value there. This would be maximal, and this would be minimal. All right, let's take a look. So let's see. I got this interval between -1 and 1 for its range. So I guess I could get -37 plus 21. And I could also get -37 times -1, which would be plus 37 plus 21. All right, repeat what I just did over there. The cosine, the most it could be is 1. So I get -37 plus 21. That's over there. Well, the least cosine could be is -1. And if I put -1, I get 37 plus 21. So I get this thing over here. So now I think I know what these values are. So what's the top number going to be? 37 plus 21 is going to be 58, right? And that's going to be y equals 58. And what's that minimum value going to be? -37 plus 21 is going to be -16, isn't it? All right, what was our question? The minimum value of that is going to be -16. All right, let's go to number 7 now. Okay, and just push this around. Old business here, right? Right thing down. I'm gonna pull these 2 on the side. All right, number 7. Boy, this is old stuff, isn't it? Find the product. I'll write this over here. 6 plus 6i minus 3 plus 3i. Now, the way I do arithmetic, the way you do arithmetic might look different, but this is 6, 1 plus I. This would be -3, 1 minus I. Well, I'm going to commute the 6 and the -3 together, and that's -18. And then I get 1 plus I times 1 minus I, which is going to be 1 minus I squared, which is going to be 2, because I squared is -1. That's -36. So I definitely found the product. No doubt about it. I found that product. But what do they want to know? They want me to write it in trigonometric form. So let me remind you about that, right? And certainly you may not remember that. You go back and review. That's the real, and this is the imaginary. So what's the number going to be? -36 plus no i's. And what would that be? Let's take a look at it. And I'm not saying it's easy for you, but it's over here. The understanding is the argument, that's the theta, is 180 degrees. And what's the r? Well, the r is just simply 36. So what's this complex number? -36 is equal to r, which is 36 times cosine of 180 degrees. We're putting it in a polar form, a trigonometric form, plus I sine 180 degrees. All right. Let's take a look at their answer. Wow. Same answer. Well, good about that. Let's go to the next one. This is number 8. And I'm looking at it. Let's see if I can read that. Let me push this stuff on the side now. Kind of done with this. And I'll just pull this off on the side. All right. It says theta is between 0 and pi/2. It says 10 sine theta equals z. What is the tan of theta in terms of z? boy, that's a tough one. Let's write this down. So I'm going to put down one thing at a time. The theta is between 0 and pi over 2, right? And I'm going to write down the sine of theta. I'm looking at it is z, right? 10 sine theta is z. So I guess I'm going to draw a picture of that, And I'm always going back to pictures because I'm getting confused by the question, right? Picture looks like this. And, theta is in the first quadrant between 0 and, 90 degrees. Ballpark it, maybe something like this over here. And I'm going to write this down now. So I'm going to write down sine of theta is z over 10. And what does that mean to me? It means that, if I looked at my right triangle over here, that this would be z and this would be 10. All right, now I want the tangent. Well, to do tangent, I need this side, don't I? So I'm going to talk about it. And what do I know about it? I know it's positive because it's in the first quadrant, right? So I think I know Pythagorean theorem, right? So 100, because that's the hypotenuse squared, is z squared. And I'm going to call this thing x plus x squared. So I'd get 100 minus z squared is equal to x squared. Now, if I didn't have a picture, I would wonder, is x positive or negative? But I do have a picture. I know x is positive. So what's that going to be? Well, the root of 100 minus z squared. So what's a tan of theta? And we'll check our answer later. Well, it's going to be the opposite, which is z, over the adjacent, which is 100 minus z squared, the root of it. All right, we're done with that page. Go to the next page. This is just a review, by the way. Okay? Number 9. I'm going to put on the side for you. Find the terminal point on the unit circle. A unit circle means a circle of radius 1 for t equals 3 pi over 4. Let's see if we can do that. Unit circle. Oh yeah, not very good job. 3 pi over 4. Well, I think you should have some idea that this thing's over here. This is 3 pi over 4. What's the reference going to be? Well, the reference angle is 45 degrees. All right, let me draw a little picture. 45 degrees, and that would be 1 root 2. But I want that hypotenuse to be 1, so it's going to be, I'll divide by root 2. Now let me just get my eraser out. What would you get? 1 divided by root 2, 1 divided by root 2. So what's this point over here? No, I'm looking at my reference triangle. I know the x-coordinate is negative, and it's 1 over root 2. And I know the y-coordinate is positive, and it's 1 over root 2. By the way, I also write this down, and again, I know some get confused by that. 1 over root 2, if you rationalize like you did in Math 100, you would get root 2 over 2. I actually prefer 1 over root 2, though, than root 2 over 2. It just looks simpler, less ink. All right, let's go to number 10. And I'm going to blow it up. And, oh boy, there's a footnote there. Okay, there's a footnote. And someone says, do I need the footnote? I don't know. Maybe you don't. Over here, next to the footnote. And it says, find the exact value of the arc cotangent of minus 1 over root 3. Let's read the footnote. That's 105, right? They said, you should know. I'm going to write this down. Maybe they're going to help me. Maybe they're going to deceive me. Who knows? They said the arc cotangent of minus 1 over root 3 is identical to the arc tangent of minus root 3. Well, which one looks easier for me to do? I think the arctangent does. If I'm going to do that, I want to remind you what we do. You're going to draw one cycle of an invertible region of the tangent function. This is pi over 2, x equals pi over 2. And this is x equals minus pi over 2. You're going to find the ratio minus root 3. And now I know the angle is between minus pi over 2 and 0. But what is the angle? Well, I bet it's something with a reference triangle. I'll put this over here. I'm going to do a reference triangle. Root 3, 1. That would be 60 degrees, right? So what's the angle? Minus 60 degrees. All right, let's write down a radian measure. Which would be minus pi over 3. All right, there. Okay, that looks good. Let's go to number 11. And I'll look at it. And I'm going to put a box on it. Again, I want to point out, if you get tired and you can't do something, you come back when you're not tired to do it. There's nothing like working when you're tired. But I'll point out, I got some troubles over here. My big trouble over here is this is going to be an arithmetic problem. And if you get tired, arithmetic can get really nasty. But anyway, let me write this over here. So the sine of u plus v is sine of u times cosine of v plus the sine of v times the cosine of u. All right, let's write this down. I know the sine of u, and that's 7 over 25. And I know the cosine of v, and that's minus 12/13. And I want to put, I need those guys. Well, what else do I need? I need to know the cosine of u, and I need to know the sine of v. I don't know those guys. What I do know, though, I do know they have a radius of 25 in this case, and a radius over here of 13. All right. They say they're both in the second quadrant. And again, I'm hoping you're getting better at this. Certainly the sine in the second quadrant is positive, and the cosine in the second quadrant is negative. I got some troubles. I don't know what those top numbers are. I'm going to figure them out now. And what's it going to be? I'm not going to say it's going to be easy for you, but there's going to be a number here. I'll just, say there's something here. I'll call it, I don't know. I guess I'll call this A. I'll call this B over here. And let me see if I can do it. All right. And I'm going to write it down for you. So it's going to be 7 squared plus A squared equals 25 squared. All right, write the other one down. So the other one's going to be like that, minus 12 squared, which is like saying 12 squared plus B squared is equal to 13 squared. And I realize people get annoyed. Do I have to do arithmetic? You probably should learn. All right, if you're tired, you can take your calculator out though. All right, so let's see. 144. I like doing easy things first, by the way. B squared. 13 squared is not that bad, but I want to write it down for you. That's 130, 10 times 13. And then 3 times 13 is going to be 39. So 169, right? So B squared, let's see, 144 from 169 is 25, right? So I hope you know that B could be plus or minus, but I'm only dealing with the plus number, so it's 5. Let me get my eraser out. I'm going to erase this over here. And I'm going to write the number down. All right, let's do the other one. 49 plus A squared. Well, let's do 25 squared now. 25 times 25. Well, I'm going to do 20 times 25, which is 500. And then 5 times 25, which is 125. And you get 625. That's an awful looking number, isn't it? I got to subtract 49 from that. Well, let's see. That would give you, let's see, 550 and 25. Take away 1. Let me do that arithmetic then. Whoops, what the hell just happened there? No, I see what happened. I touched that button. All right, so let's see. 51, 61, 71, 76, 576. All right, so last didn't look at that. This is killing me. Right, this is absolutely killing me. What I do know about A in this case over here, A is a negative number. I know that. All right, so that question becomes is, do you know the square root of 576? All right, say 24. All right, let me put that down for you. Who knows? Maybe I'm wrong. Let's see, 2 times 24 is 48. So that's 480. And 4 times 24 is 80 and 60, 96, right? And that's going to be 576. Geez, that was luck. So I'm write that down for you. Get my eraser out. And again, I know for some, especially if you're really poor at arithmetic, this is really annoying. But I think I'm ready to write it down now. All right, what's the sine of u? 7/25. All right, what's a cosine of v? Minus 12/13. What's a sine of v? 5/13. What's a cosine of u? Minus 24 25ths. By the way, the numbers did work out pretty nice. All right. So the same denominator in both cases. And 13 times 25 is 250. And then 75, which is 325. We'll check the answer later, by the way. 7 times 12, that's 70 and 14, minus 84. And 5 times minus 24 is minus, let's say, that's 120, right? Well, if I do that arithmetic, I would get 204, minus 204 over 325. Take a look. Wow, got that one right too. Yeah, not bad. Number 11's got a 12. And I don't know, I guess I could pull this on the side, right? And I got 12 and 13 to do, right? We've already done 10. Let me just box them out, pull them out. A big piece of paper, right? You know what? I made a mistake there. I didn't box enough. And push this all away, push this away. And let me just pull this up, pull this out. Let's do 12 first. I can square that. And what would you get? Sine squared t plus 2 sine t cosine t plus cosine squared t. Well, I see a Pythagorean identity there. And what's that going to be? It's sine squared plus cosine with 1, right? So 1 plus 2 sine t cosine t. You should recognize some identities, by the way. And I'm seeing one of the identities that I know, the Pythagorean one. I also see a double angle. And what's that? 2 sine t cosine t? It's actually just sine 2t. Pretty simple. Let's go to the next one. Ooh, this looks strange. 1. This would be 1. Let's see, cosine of minus x, the same thing as cosine of x. It's an even function, plus 1 over 1 minus cosine of x. Common denominator, we'll do that later. The numerator, and the numerator, the top would just be 2, right? That's pretty simple. What's the denominator going to be? 1 minus cosine squared. And I should recognize that guy. That's just simply sine squared, isn't it? And what's that give me? 2 cosecant. I really messed up with the penmanship, didn't I? All right, let's go to the next page. And we'll do problem number 14 next. 14 looks like a big problem. And blow it up. And we'll start talking through it. And I got troubles right from the beginning because you really remember when we do these problems, everything had to boil down to a sine, cosine, or a tangent. And I've got a mixture here. So what I'm going to claim over here is I'm going to just maybe pull it to the side, this here. And I'm not going to look at my k. Look at this over here. So I'm going to write this as 2, 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. Well, let's multiply this out. You would get 2 minus 2 cosine squared x plus 3 cosine x minus 3. I'm going to keep rewriting it. Minus 2 cosine squared x plus 3 cosine x. That would be minus 1 equals 0. I'm the kind of person who doesn't like a negative coefficient on the square term. So I can multiply both sides by minus 1. And what do you get? 2 cosine squared x minus 3 cosine x plus 1 equals 0. I'm going to factor if I can. Let's see. I say minus minus. And what does that give me? 2 cosine squared. Looks good. Minus 2 minus 1 is minus 3. That looks good. And plus 1. I want to go back. I can't remember if they want me to find all solutions or just some solutions. I'll find all solutions here. Oh, let's look for them. So let's do this. Let's just do just one first over here. And when would this be true? When the cosine is equal to 1. And so I think that's pretty easy to write down. And I'll tell you why. If I look at the cosine curve, the cosine curve becomes 1 at the multiples of 2 pi. Right, I'll write that down for you. So x would be any multiple of 2 pi. I'll write that down for you. So 2 pi k, with the understanding k is some integer. All right, let's do the next one. And this one becomes true when the cosine of x is equal. When I say true, it becomes 0. I want the product to be 0, by the way, 1/2. Now the question is, where does that occur? Well, I'm looking at my picture here and over here. And I should have a good idea about what that is at this point in my career. Right? When I say that, if you study the material, that's what I mean by your point in a career. So what's the reference then? What angle would give you a ratio of 1/2 as a reference triangle? And that would be 60 degrees, right? I know I'm speaking in degrees. All right, so I'm going to write the first one down. And that's over here. That's 60 degrees. I'm gonna go away from degrees later though. Plus every 360 degrees, again, k, we're some integer. What's the next one going to be? Well, it's in that last quarter, which would be between 270 and 360. It has a reference of 60, so it'll be 300 degrees. Plus 360 degrees, k. I'm going to write my final answer down, and then we'll look at the k. So x equals, well, 60 is going to be what? Pi over 3 plus 2 pi k. What's 300? Well, it's going to be 5 pi over 3 plus 2 pi k. And And last but not least, we still have 2 pi k. All right, let's look at our k, see how we did. See if we got it. Miracle. Let's keep going. It's another solving problem. Pull it on the side. Sorry about that. And let me take a look. This one's not all solution. This is a solution between 0 and 2 pi. I got another trouble. I got mixtures of arguments. One's 2x, one's x. Let's write this down. It's number 15. Well, I don't need to put 15. I got 15 there already. So I'm going to write it down as the cosine of 2x is 2 cosine squared x minus 1. That's this guy right here. Plus 3 cosine x plus 2 equals 0. Boy, this is deja vu, isn't it? It's almost like we just did it. A little different though, I know that. Whoa, when does this become true? When the cosine of x is equal to minus 1. Where does that occur? Well, the interval we're talking about 0 to pi, 2 pi, that only occurs at pi. Let's do this one. When does this become true? When I say true, it becomes 0 because it makes the equation true. This is when cosine x equals minus 1/2. Where does that happen? Here and here. Well, I'm going to do it in degrees, but what's the reference angle? I'll write this down for you. Well, what gives you a ratio 1/2 for a reference? That would be 60 degrees. We just did that, right? So what do I got? It's in the second quadrant between 90 and 180. So it's 120 degrees. It's also in the third quadrant between 180 and 270 with a reference of 60, so it's 240 degrees. Again, I want to speak in radian. I'm going to go to radian now. So, you know, if I looked at the numbers in degrees, it would be 120 degrees, pi is 180 degrees, and 240 is 240 degrees. Let's write down the radian measures though. So, you know, I'm looking at it basically has to do with multiples of 60, right? 60 would be pi over 3. So this is 2 pi over 3. We'll look at the key later. This is 3 pi over 3, which is just pi. And this would be 4 pi over 3. Again, I want to emphasize, look at the k. And you really do want to look at the k. All right. Let's take a look. I was 15. I think I'm ready to do 16 now. And I want to see if I can do it. It says find the exact value of the tangent function of theta if the point minus 1,4 is located in the terminal side of the angle in standard position. Let me write this down then. And what's that going to be? Minus 1,4. And that's a standard position problem. And this is theta. And the abscissa minus 1 and the ordinate is 4. And what's the tan of theta defined by 4 over minus 1? I'll write that down. Which is minus 4. All right, let's go next page. Oh boy. That's one we did in the past. I'm going to hold off on that. This is an old problem. We did that in the law of sines, law of cosines section. This is going to require the law of sines. And we did that one already, all right? I mean, I think we did them all already, but I'm going to point out, I would go back to the old problem, and there is a video posted for that one there. You can search for that one if you want, right? It's in a law of signs. What's the problem with this is ambiguous and there's two different results. The results are listed for you. I'm going to go to problem number 18 now. I'm going to pull it off onto the side. And it says over here, find a unit vector. Well, that should be easy. So U, give me a second. U is a vector, minus 6, minus 3. And how do I find a unit vector? It's super simple. Take this vector and divide it by its length. Well, let's do the length. The length of U is going to be 36 plus 9, the root of that, which is the root of, did I do that right? 36 and 9, 45, right? Which is going to be, let's see, 9, which is 3, root 5. I'll write that down. And what's U? Minus 6, minus 3. I want to point out that's a scalar multiple. So it's 1 over 3 root 5 times minus 6, minus 3. Let's do that. What do you get? Minus 6 over 3 root 5. And you get minus 3 over 3 root 5. And yeah, I'm going to reduce it. And what do you get over there? Let's see, you would get minus 2 over root 5. And you would get minus 1 over root 5. Not bad. All right, that was 18. Let's go to number 19. And again, sometimes you really, I would say sometimes when you take an exam, you might get sick and you say, I can't remember anything. And that happens. It really happens a lot to students. They do, I would say not enough practice. All right, let's take a look at this one over here. So I'm looking at it and I just want to remind myself about the arc cosine function. Right, so what are we talking about? In like invertible regions of it, right? Let me put that down for you. What's the invertible region cosine? Something like this over here. And where would the ratio 2/3 be? It would be over here somewhere, all right? Now, what do I know about that? I know it's between 0 degrees and 90 degrees. And that's good news for me because I'll be honest with you, if it wasn't, I'd have trouble. I don't want trouble. Why do I have trouble? I want the tangent. And the tangent in this range is going to be a positive number. All right. Now, what do I know? I'm going to talk about right triangles to do it. And the reason for that is, I know the theta is between these two numbers. I may not know what it is. All right, a little right triangle down here. That'd be a good right triangle. Well, 2. This would be 3. Pythagorean theorem. I get 9 equals 4 plus something over there squared. I'll call it, I don't know, b squared. And that would be root 5. And what's the tangent of that angle? I don't know what the angle is, but I know its tangent is root 5 over 2. All right, pretty simple. Let's go to number 20. Oh boy, I got a lot of work over there to get rid of now, don't I? Let's go 20 and 21. Okay, let's take a look. I don't know, I'll pull it on the side. By the way, I know there's Sage code there. I'm not looking at the Sage code. Find the exact value of the cosine of 2 theta if the sine of theta is equal to 1/3. Let's write this down, number 20. The cosine of 2 theta is 2 cosine squared theta minus 1. It's also 1 minus 2 sine squared theta. It is also cosine squared theta minus sine squared theta. Now, by the way, I only know this one. And why is that? I got this right over there. Let's write this down. The cosine of 2 theta is equal to 1 minus 2 sine squared. And what's sine theta? 1/3. Let's do arithmetic and we'll check it. This is going to be 1 plus 2/9. I'm sorry, I made a mistake already. It's 1 minus 2/9. And that would be 9/9 minus 2/9, which is 7/9. Okay, let's keep going. And we're going to do number 21 now. All right, I'll pull out a side too. I bet the answer's on the next page though, huh? I don't have an answer in front of me. Let's see if we can write this down now. Yeah, one step at a time, right? The cosine of minus k is cosine of k. It's an even function. The sine of 2k is 2 sine k, cosine k. Oh, gee, the sine of minus k is minus sine k. So this is plus sine k. Whoa, they're really killing me here. The cosine of 2k is going to be, you know what, let me simplify this first. This is going to be cosine 2 cosine squared k sine k plus sine k. Let me do the cosine 2k now. What am I going to do there? I get so many different forms of it. I'm going to put down, well, you know what I'm going to put down is I'm going to put down 2 cosine squared k minus 1. Let's write that down now. So 2 cosine squared k minus 1. Let's write this down now. 2 cosine squared k sine k. Let's take a look at that. Plus 2 cosine squared k sine k minus sine k. Okay. And what do you get over there? 4 cosine squared k sine k minus sine k. Let's keep going. Who knows where it's going to go? Sine k times 4 cosine squared k minus 1. I guess that is simpler. I don't know if that's our answer though. I'm going to look at it. I'm going to, next page, see what they got. I'm going to pull it over too. Whoa, it's not even there. Let me go backwards. Did I cover something up here? I got to look at my notes, by the way. And the reason I wonder if they got an answer there. And that's what, number 21, right? We did a lot of problems today, didn't we? I'm still looking at my answer key. I want to make sure I got something there. Oh, you know what? That's a tougher problem. I got to be honest with you, though. This is an acceptable answer. All right? It's an acceptable answer. But I do want to point out I didn't really think carefully about that. And let me just write that again for you. I just looked at the answer. And but that's not a bad answer, though. I'm not saying it's a bad answer. But I want to point out, I just wasn't thinking. All right? And that happens sometimes. I'm a little tired. It's 21. All right? So I'm going to write this a little bit differently and point out what I did not see, which I apologize for not seeing it. I should have noticed it right away. And what should I have noticed? This is a sum formula. And what is it a sum? It's a sum of sine 2k plus k, which is going to be sine of 3k. And I just didn't see it. I hate to say it. I didn't see it. All right. And it happens sometimes. What happens? I looked at the answer key and then I noticed I didn't get the same answer. And this one, it's simpler, but I can tell you that this is actually simpler. All right. That happens sometimes. All right. Let me take a look and let me go to the next page. And that was numbered, just to make sure, at 21. I'm going to go to 22 now. And 22 says, it says convert the polar equation to rectangular form. All right, I think I can do it. I'm going to multiply both sides by r, and what do you get? R squared equals minus 4r times cosine of theta. Do I know what r squared is in rectangular form? Yeah, it's x squared plus y squared minus 4, and r cosine theta is just simply x. All right, I'm going to solve this thing. You don't have to, though, but I'm going to solve it for 0. But that's a fine answer right there. If you solve that for 0, what do you get? X squared plus y squared plus 4x equals 0. I got this over here. By the way, I'm not going to say they asked for it, but the bottom line, I think you should probably recognize that guy. And someone says, I don't recognize. I know it's the answer, by the way. I want to go through it with you, though. And I'm going to put this over here. I want to recognize this guy. What do you get? X squared plus 4x plus y squared is equal to 0. Complete the square. Plus 4 plus 4. This would be x plus 2 squared plus y squared is equal to 4. I recognize this is a circle now, where the center would be minus 2, 0, and has a radius of 2. Looks like this over here. All right, fairly easy. They didn't ask you to do that, though, by the way. Let me go to 23. And 23, I'm going to read it to you. I'm going to pull it on the side. Excuse me 1 second. An object is traveling around a circle with a radius of 10 centimeters. If in 20 seconds, a central angle of 1/3 radian is swept out. Let me write this down. And again, you might say, I can't remember any of this material. It's like you're giving me something I've never done before. It happens. People can't remember. But I'm going to say that's an omega. What's omega? Angular velocity. Well, what's the angular velocity? I'll write it down. It says if in 20 seconds, a central angle of 1/3 radian. So it's 1/3, no unit on that, every 20 seconds. And that's going to be 1 over 60 seconds. Someone says, what does that mean? It means it does 1 radian every minute. All right. Now, what else do they tell me? They tell me the radius of this circle is 10 centimeters. Okay. I'm reading this, by the way. It says an object traveling around a circle, radius 10 centimeters. If in 20 seconds, the central angle of 1/3 radian swept out, what's the linear speed? Well, let's remind you about this. Maybe you can't remember, but I think we have some relationships, right? S equals r theta. I think you've seen this before. If you divide both sides by t, S over t is velocity, r, and omega over t is angular velocity or angular speed. So what do we know? Well, I'll write it down. We know r is 10 centimeters, and we know omega is 1 over 60 seconds. Well, what do you get over here? You would get 10 over 60, which is 1/6. The bottom unit is seconds, and the top unit is going to be centimeters. So what is it? 1/6 of a centimeter per second. All right, let's go back to problem number 24. And let's take a look. This one I could probably read. Whoops, let me just straighten it out a little bit. Get my eraser out too. right, let's talk a little bit. The cotangent of theta is positive, but the secant is negative. All right, so let me go through this with you. So this might require thinking, or somebody said it doesn't require any thinking at all, but all trigonometric functions in the first quadrant are positive. Right, every single trigonometric function in the first quadrant is positive. It's the other ones that kind of change signs. So let's talk about the cotangent being positive. That means there's another quadrant where the cotangent will be positive, and the cotangent is not positive in the second quadrant. It's not positive in the fourth quadrant, but certainly the cotangent is positive here. Just make sure that the secant is negative in that quadrant, and it is. It's got to be the third quadrant. All right, feel good about that. Let's do 25, and that'll be the last one for this session. All right, so what do they say? Wow, they say something pretty unusual. They say simplify this guy over here. And my claim over here is, I'm still going to go back to what the basics are because I'm confused. And we'll put this down over here. And I'm going to put the invertible region as sine function is like this, right? It's like that. And that goes between minus 90 and 90. And this is the invertible region sine function. Now I'm looking at this and it says the arc sine of x over 3, but it says the x has to be better than 0 and less than 3. So the ratios would have to be over here. What does that mean? My angle has got to be between 0 degrees and 90 degrees. So this is going to be a right triangle problem. Let's write it down. I may not know what the theta is, right? But I do know the sine of theta is going to be x over 3. Pythagorean theorem, this side over here, well, it's in my first quadrant. It's got to be a positive triangle, right? No negative sides over here. The root of 9 minus x squared. And what's the tangent of that? It would be x over 9 minus x squared. And we're done. So I'm going to call it quits. Now, certainly when I say call it quits, you shouldn't call it quits. You should keep working. We got to problem number 25, and we'll do others. I know there's a lot of work here. We're just reviewing, and the more reviewing you do, the better it is for you. Thank you.